What is up, guys? Welcome to your 40th physics lesson, and in this lesson I want to talk to you guys about two different types of waves: transverse and longitudinal. So the easiest way for me to explain this would be first to basically give you an example of a transverse wave. So we'll say that you went to Kmart. Here's you right here. We'll name you Bob. And you went to Kmart, or did I say Walmart? Can't even remember. And you bought a Slinky. So then you're like, oh my god, this is going to be so fun. I'm going to invite my friend Gina. Must be your girlfriend. Her name is Gina over. And you guys are going to play with your Slinky. So what you did is you're like, Gina, stand over there. I'm going to get this thing out of the box. And I'm going to hold on to one end. And you're going to hold on to the other end. So you did that. You guys are both holding one end of the Slinky. But then you thought it would be funny to start whipping your arm up and down in this direction right here. Well, whenever you did that, what it did was it caused the Slinky to create these waves that kind of look like this, and they went all the way down towards Gina. Now, aside from, having fun, what you notice, since you watch the new Boston physics tutorials on YouTube, that you were actually making transverse waves. Now, the definition of a transverse wave is a wave that vibrates perpendicular to the motion of the wave. So here is the motion or general direction of the wave going from Bob to Gina. And of course, whenever they say vibrations, they're talking about what sort of movement caused this wave. So as you can see, when you moved your arm up and down, it caused the wave to go left to right. That's why they say perpendicular, and that's the definition of a transverse wave. Now, what the heck would be this other type of wave? Well, this other type of wave is called, it has a couple names. Some people call it longitudinal, other people call it compression waves, and you guys are going to see why in a second. So Gino's like, you know what, that is so immature, Bob, making transverse waves, going all up in my body like that. And then she left you, so you went ahead and, since she took your Slinky, you had to go get another Slinky at Walmart. So you decided that with this one, no more making transverse waves. Instead, you, whose name is Bob, and your new girlfriend, whose name is Bertha, decided to go in your kitchen and play with your new Slinky. Now, what you did this time, since you decided, you didn't want to lose a girlfriend, you took one end of the Slinky, gave it to Bertha, while you held the other end, but this time you took the coils and you formed kind of a compression. You pulled all of the coils on your side together. Now, over on her side, she didn't do the same. So if you can look at my little diagram, let me change colors for a second. This area right here would be the compressed area, and this over here, of course, has no compression whatsoever. So basically, a Slinky is like a big spring, and what you're doing is you're taking a portion of that Slinky and squeezing the coils together, causing it to be compressed right here. Now, obviously, once it's released, the compressed portion of the Slinky is going to travel down towards Bertha until it eventually hits her and she's going to absorb some of the energy. So that is basically the definition of a longitudinal or compression wave. You guys can see why they call it a compression wave, because it's a wave that vibrates in the same direction as it is moving. So both of the waves are traveling in the same general direction. However, the origin of the waves, while this one was up and down, this one was parallel or in the same direction of the motion. So just remember that both types of waves, even though they transfer energy, and especially whenever we're looking at a lot of the formulas, they use the same formulas. And what do I mean by that? Both of these waves, even though they look a lot different whenever I'm explaining them, they both can use the formula velocity equals wavelength times frequency, and a bunch of other formulas as well. However, in the real world, this is how they travel, and different types of energy use different types of waves that they travel through. What do I mean by that? Well, that's probably a weird way of saying it, but light waves, they use this type of wave to travel, transverse, and things like sound waves, they use this type, compression waves or longitudinal. Now, before I let you guys go, I want to mention a couple things that are going to bug me if I don't mention. But it's kind of important to point out because even though you're probably not going to find this in your physics book, this is always a concept that kind of bothers me, and especially when I'm trying to explain these things to people and they don't get it, this is what I want you guys to know. So, even though, well, how can I say this? Notice what is happening when these waves move along the slinky, whether it's the transverse or longitudinal waves. The waves themselves, and if you just looked at, this from a distance, it would look like the wave was moving down the slinky, such as in this case, it's going to look like these waves between Bob and Gina are actually moving towards Gina, but the waves themselves are actually not moving. The individual coils, as you can see, are not moving. So if you were to take one of these coils, whether it was, a coil that was right here or a coil that was right here, and you painted one of these coils pink, you would see that no matter what types of waves that you created, these coils would not move down the slinky. They would just vibrate back and forth, back and forth. So just remember that. Even though it looks like the waves are actually going from Bob to Gina or Bob to Bertha, the matter does not get transferred. No matter whatsoever gets transferred from Bob to Gina. It's only the energy from person A, Bob, to Gina, person B. So I just, like to point that out because this is actually true for all types of waves, that waves do not transfer matter, they just transfer energy from the source, which is, in this case, Bob.